is like the project involves deploying a machine learning model to predict flight price based on user input. It includes a front end for the user interaction, a backend for handling requests and predictions, and a machine learning model for the predictions. The entire system is deployed on the platform like GCP, and I have showing it on GitHub. Here is the user interface. Here I have to select the airline. Like right now I am selecting Air India. Then from I am selecting here Bangalore to I am selecting here Delhi. It is shows the number of stops if because here we are estimating the ticket price. So we have entered the zero number of stops, direct flight, direct connecting flight. The day like around 30 July 2024. Let's say our departure time it will be around 6:45, around 6:45, and destination arrival time is around uh, let's say 7:10. It's 7:10. Is there any long layover or is any business class we can changes on the basis of it? On the basis of flight fare will changes. Like we don't have no information about it, then no info. How many adults? Let's say I'm booking ticket for two. I'm a student. Yes, I'm a student. Let search it and see our prediction. Here I found out the price is 8106. First of all, we'll divide the project on the basis of front end and back end. Let's see our front end. For front end, we have index.html, which is present on template folder. The purpose of this, the purpose is the purpose of this file is to show the main interface to the user. It contains structure and layout of the web page where user input flight details. The key points are like HTML form. It contains input fields for flight details such as departure, city, arrival city, date of journey, and more. And also it considered as a submission form where the form data is sent to the backend for the processing where user have to submit the form. The complete index.html file is like this. Then I also have in front end like CSS file where the purpose of the file is mainly the styling the information for index.html. It ensures the web application is visually appealing and user friendly. Here, the styling it provides CSS rules for the elements like form fields, buttons, labels to improve the aesthetics. Responsiveness it also increases the responsiveness of the web page, ensures the web page looks good on various devices. The complete CSS file is like this. Then I move forward to my Jupyter Notebook model.ipynb file. The purpose of this file is to use the data exploration, pre-processing, model building, and evaluation. Like the key points I have here done the EDA, perform the exploratory data analysis to understand the data, pre-processing, and I have here handled the missing values, encode the categorical variables, scaled the numerical data. Also, I have done here model building, trained various models and evaluates their performance, and I have saved my model in joblib file. That are the first of all I imported the all the important libraries that is needed for this IPYNV file. Then this is our data is looks like this. Then I find out the data types of the each column. Then I have checked the zero, the number of zeros present in it. Then I have done the data pre-processing and removed the zero files and null value files. The complete data preprocessing is looks like this. I have used for the preprocessing label encoder I have used here to encode my data. The entire file is look like this right now. And here for the data analysis, complete data analysis, I have used Seaborn, Matplotlib to show the different type of like average prices by the airlines. I have used here. Seaborn I have used here. Flight price by source and destination. Total stops versus price and price versus duration also. Here I have also presented the heat map of the complete data where the you observe that the red columns are the completely correlated. Price distribution by the journey month. Here I have subdivided my data into X and Y for the train and test purpose. And this is my process pipeline. Here I have used the KNN in imputer, and here I have used the multiple machine learning algorithms to know which algorithm best fit our model. And from the loss, we have R2 score and the mean square error. We have found that the best model is looks like the gradient boosting regression model. Here I have scaled my data. The model looks like this. After I have to increase my accuracy, I have also fine-tuned my gradient boosting algorithm. As a final result, I have found out like 88% accuracy, and I have imported the joblib to save my model. Here I have saved two joblib files, flight fare underscore GVR joblib file and flight price underscore scalar dot joblib file. After that, the second we move forward to the backend. This is the main backend file that sets off a flight application to handle user requests, process inputs, and return predictions. The key points are like the route setup defines the route for the web application, where I have set the route setup here, route setup, and the modeling loads the preprocessing model for the scalar, preprocessing handling, preprocess user inputs, make predictions, and returns result for the user. That's why I have done it. Here I have imported the important files that present in it. Then I have loaded the jobly files that I have already saved in my IPYNB file. Then if the render template is used to fast when we are click on our link, it will fast move to the index.html. For the calling, I have used the post method, and it will get simple input from the form that was present already. I have shown in my index.html file where the airline data, date of journey, source, destination, total stop, additional information, departure time, arrival time, and travelers, all the data it will collect from the index.html. Then I have extracted day, month, all of the things I have written in this file.